Hello guys, in this video we are going to discuss about the complete math solution of IBDP November HL 2018. So again, welcome to IB 360.
So the first question is, consider two events A and B such that P of A is equals to P of A complement intersection B is equals to 0.4 and P of A intersection B is equals to 0.1. Now by drawing a Venn diagram or otherwise find P of A union B. So we are doing this particular problem. So you will draw the Venn diagram and we will try to understand that. So before drawing Venn diagram, the most important thing that we are writing down, that is P of A is equals to P of A intersection A complement intersection B is equals to 0.4. Now what does it mean? It means the complete A set as well as the A intersection B set, both the values are equals to 1. So now we will do that problem and we will see what basically this is. So first we are trying to draw the Venn diagram. So as I am drawing freehand, so please pardon me for that. So this is one set box and we are drawing the two sets. This is set A, and one more thing you can see, we have P of A intersection B. So obviously the B set will intersect the A set. This is all the obvious thing. Now the thing is, P of A intersection B is 0.1. So this value is 0.1. So this is fixed. Now the thing is, P of A complement intersection B. So P of A complement intersection B, it means P of A complement means this is the complete A set. So A complement intersection B means only this particular portion. Only this particular portion. Just I am giving the example. Only this particular portion will be P of A intersection B. This section will be called as P of A complement intersection B. So this value is given to be 0.4. So this is 0.4. Now we need to find out now you can see P of A is 0.4. So the complete A set, this is the complete A set. So basically P of A is nothing but P of A intersection B complement plus P of A intersection B. So basically if this is the formula, then only this particular portion will be the particular thing. Now the complete A set value is 0.4 and the intersection value is 0.1. So ultimately this value will be 0.3. So because the complete A set, now you can see the complete A set, this is the complete A set, this area is the complete A set. Now it is becoming 0.4. So ultimately it is given here. So now we have to find out P of A union B. Now P of A union B is basically nothing but this, all the three values will be added. So 0.3 plus 0.1 plus 0.4 is equals to, here just add the values, that is 0.8. This will be the value of P of A union B. But if you want to do this from formula, that is P of A union B is equals to P of A plus P of B minus P of A intersection B. So if you want to use this formula, now P of A, the complete set is 0.4 plus P of B, the complete set is 0.5 minus P of A intersection B is 0.1. So this is 0.9 minus 0.1 is equals to 0.8. So in both the ways we have done the first problem. Now the second problem, show that the events A and B are not independent. So the events A and B are not independent. So if two events are independent, then P of A intersection B must be equals to P of A into P of B. Now you will check all this. Now P of A intersection B is given as 0.1. So it is 0.1. Now P of A and P of B, we will check that. So P of A into P of B. So this is equals to P of A. The complete P of A was, as from the previous slide you can see, or else I am just drawing the rough sketch here. So this was our A set, this was our B set, this is A set, this is B set. The intersection value was 0.1, this was 0.3, and this was 0.4. So P of A is 0.3 plus 0.1, so 0.4, into P of B is 0.4 plus 0.1, so that is 0.5. So ultimately the value of P of A into P of B is 0.2. So you can see this value P of A intersection B and this value P of A into P of A into P of B, both are not same. So P of A intersection B is not equals to P of A into P of B. So that's why events A and B are not independent. So this problem is also done. Again, one more thing, if the two if the two values are independent from the graph also, you can see here the intersection is done and all these things are happening. So that's why obviously A and B are not independent. Okay, so this problem is also done. Now we will move towards the next problem. A team of 4 is to be chosen from a group of 4 boys and 4 girls. Find the number of different possible teams that could be chosen. So the thing is, find the number of different possible teams that could be chosen. This problem is from the combination part. We need to find out the combination. Now here probability also lies there, but we need to find out different possible teams, different possible combinations. So just the first problem is just the combination. So just before proceeding to the combination part, just the thing is, there here are the 8 people are there. So 1 2 3 4 5 6 7 and 8. So this is one boy, this is another boy, this is another boy, this is another boy, this is another girl, this is another girl, this is another girl, and this is another girl. So 8 people are there. So 8 people are there, and we need to choose uh, from these 8 people, 1 2 3 4 5 6 7 8. From these 8 people we need to find out, choose a group of a team of 4. So we need to find out a team of 4. So we need to find out the team of 4. So now 8 positions are open. 8 positions are open, as you can see. 8 positions are open, and we need to fill the position in 4 cases. Just think it in this way. In 8 chairs there are 4 boys and 4 girls, and there are 4 empty chairs, and we need to fill the 4 empty chairs using the boys and girls, and only 4 chairs are given. So here the combination that we will use, the particular formula that we will use, that is NCR, the combination part. In the number of total number of cases, and R where we need to fit it. So now here N is 8 and R is 4. So basically we need to find out 8C4. We need to find out 8C4. And from here the formula is, the formula for NCR is equals to N factorial divided by N minus R factorial, N minus R factorial into R factorial. So N minus R factorial into R factorial. So here 8C4, so it is equals to 8 factorial divided by 8 minus 4 factorial into 4 factorial. So we are getting 8 factorial divided by 4 factorial into 4 factorial. Now 8 factorial, we can divide it in 4 factorial into 5 into 6 into 7 into 8 divided by 4 factorial into 1 into 2 into 3 into 4. Now let me elaborate this particular thing. 4 factorial, after 4 factorial, if we multiply 5, 6, 7, 8, it becomes 8 factorial. And in 1 4 factorial, we just elaborate it. So this is cut. Now from here we can see 3 2 6, then 4 2 8. So ultimately the answer is 5 into 7 into 2 is equals to 70. So find the number of different possible teams that could be chosen. The number is 70. So 70 possible teams can be chosen. 70 possible teams can be chosen. So this problem is done. So answer is 70. Now we will move towards the next question. Find the number of different possible teams. This answer was 70, just for noting down. Find the number of different possible teams that could be chosen given that the team must include at least one girl and at least one boy. So here we need to choose the team where at least one boy and at least one girl is there. So ultimately the thing is, again we just are trying to give the example. So here boy, 4 boys are there, 4 girls are there, and find the number of different possible teams that could be chosen given that the team must include at least one girl and at least one boy. So from here this is first position, second position, third position, fourth position, fifth, sixth, seventh and 8, and there are 4 another chairs, obviously 4 chairs, and at least one boy and at least one girl must be there. So now the number of chairs that are empty are 1 and 2. Now the thing is, just understand, if this is the case, so what is the opposite case of this? The opposite case is that all boys are filled, all boys are in one team, and all girls are in one team. The possible team that can be formed by all the boys in one team is 1, and the possible team that can be formed by all the girls in one team is 1. So if we deduct from 70, 70 is the total number of possible teams that can be formed, and if we deduct all boys in one team and all girls in one team, then we will find out the number of team that must include at least one girl and at least one boy. This is very easy. So in this way we can do this problem just without any combination or any process. Just from the first problem we can do the second problem. So ultimately the answer is 70 minus 1 plus 1, because in one team all boys are there, in one team all girls are there, and in the rest of the teams at least one boy is there and at least one girl is there. So in this way we can find out 70 minus 2, so the answer is 68. So in this way this problem is also done. So thank you for watching IB360. In next videos we will discuss the next problems. Thank you. So now third problem is, consider the function gx equals to 4 cos x plus 1, a less than equals to x less than equals to pi by 2, where a is less than pi by 2. The value of a is less than pi by 2. Now the number a question is, for a equals to minus pi by 2, sketch the graph of y equals to gx. Indicate clearly the maximum and minimum values of the function. Now the thing is, we will draw the graph here, but before that please try to understand the fact that is I am drawing in freehand, so the minute differences will be there. So the thing is, the graph of cos is like this. We all know the graph of cos is like this. Now the thing is, here as you can see, the function is g of x is equals to 4 cos x plus 1. So obviously the graph will not be like this. So this is the point of plus 1 and here this is the point of minus 1. So as you can see, the graph, it is 4 cos x. So ultimately the value will be 4 and it will be shifted along the y-axis, and the shift, while we are doing the shifting, there must be one constant y value, that is 1. So that's why the fine curve will be, the refined curve will be like this. Just if we shift this, so here it is plus 1, so by plus 1 it is shifted, and if it is shifted by plus 1 without, if the function is, just take one example, if the function is cos x plus 1, then the curve will follow like this. Then the curve will follow like this, and here it is plus 2. So in this way, the shifting will be done along the y-axis. You need to understand this particular process. Now come to this part. This is 1, this is 2, this is 3, this is 4, and this is 5. And in here, it will be minus 1, minus 2, minus 3. So and here it is minus pi by 2, and it is plus pi by 2. Now the thing is, as it is 4 cos x plus 1, so the value will reach to 5 instead of 1. So previously it was taking the value of 1, but now it will take the value of 5, just because 4 cos x plus 1, because at cos 0 the value of cos 0 is 1. So ultimately 1 into 4, that is 4, plus 1 equals to 5. And if cos x equals to 0, then the constant value of y is 1. So that's why the other 2 points will be here and here. Please keep in mind, it will not touch the x-axis when the limit is from minus pi by 2 to plus pi by 2. Please keep in mind, it will not touch the x-axis when the point is from minus pi by 2 to plus pi by 2. So the graph will be like this. So this will be the graph of this particular, here one small mistake, because I am doing freehand, that's why. So this will be the graph of gx equals to 4 cos x plus 1. Remember the limit, that is minus pi by 2 less than equals to x less than equals to pi by 2. So in this particular limit, the graph will look like this. So for a equals to minus pi by 2, sketch the graph of y equals to gx, and now we need to indicate clearly the maximum and minimum values of the function. Now to note the maximum and minimum values of this particular function, so you can see obviously this particular point is the maximum value. So it is maximum value, and maximum value, the gx is g of 0 is equals to 5. This is the maximum value, and here it is minimum value. This minimum value, at minimum value g of minus pi by 2 is equals to 1, and again here is another minimum value, that is minimum g of plus pi by 2 is equals to 1. So in this way, 2 minimum values are there. So I am writing down here, that is maximum is g of 0 is equals to 1 is equals to 5, and minimum at g of minus pi by 2 is equals to g of plus pi by 2 equals to 1. So the function has 2 minimum values. For 2 values of x, the function has minimum values, that is 1. Minimum value is 1 for 2 x values, that is minus pi by 2 and plus pi by 2, and the function has 1 maximum value, that is 5 at x equals to 0. So the first problem is done. Now we will move towards the second problem, that is write down the least value. The second problem, here it is described, write down the least value of a such that g has an inverse. So again we will draw the particular curve 1, 2, 3, 4 and 5. 1, 2, 3, 4 and 5, because it was the maximum point, and here it is minus pi by 2 and it is plus pi by 2. This is x-axis and this is y-axis, and we have already discussed the graph will look like this. This point, and this point, the graph will be in this particular value. Now the thing is, if we draw the graph in between these values, then this particular graph, when the limit of x is from minus pi by 2 less than equals to x less than equals to pi by 2, when this is the case, then this curve will not pass the horizontal line testing. Then this curve will not pass the horizontal line testing. As you can see, we are drawing the horizontal line and it is not passing the horizontal line. Now the thing is, we need to find out the least value. We need to find out the least value of a. So here, as you can see, we need to find out the least value of a. So the value of a here, the value of a is 0. A is equals to 0 here, and here a is becoming negative and here a is becoming positive. Now see, whenever we are going left to a equals to 0, it will not pass the horizontal line testing, because for being inverse the function must be 1 1 and on 2. So that's why we will use this particular horizontal line testing to get the result. So that's why you can see at a equals to 0, from here only only this portion will have the inverse. If we give the limit only this portion, then it will have the um, inverse. But if we take value of a negative, that is less than 0, then it will not have the inverse. So that's why the proper inverse will be, just see the graph. The inverse will be from here only this portion will have the inverse. So from here to here, this portion will have only the inverse. And now if we try to do the horizontal line testing, as you can see, it is now passing the horizontal line testing. So that's why in this way we can get the inverse value. So write down the least value of a such that G has an inverse. So the least value of a is 0. So the function will have inverse in this particular range, that is 0 less than equals to x less than equals to pi by 2. In this particular range, the function will have the inverse. So G inverse will exist only in this particular range. Now for the third question. See, write down the domain of G inverse. Write down the domain of G inverse. So again, just we are writing down, we are drawing the inverse function that we have used. So 5 are there, and so this is minus pi by 2 and this is plus pi by 2. So we are getting, again, this will be the value of minimum, 2 minimum there and 1 maximum there, but this portion we cannot take for the inverse. So as the inverse exists, we will only take this particular portion. As you can see, this is the y value and this is the x value. Now the particular thing is write down the domain of G inverse. So as you know, the for a equals to 0, here a will be 0. Now the thing is, the question is find out the domain of G inverse. So domain of G inverse x, domain of G inverse x is equals to nothing but range of G of x. As you know, domain of G inverse x is nothing but range of Gx. Now range of Gx for this particular period, the range of Gx is nothing but from x value to 0 to pi by 2. So x value is taking 0 to pi by 2, and that particular x values, the range is from this value is 1. So this is 1, 2, 3, 4 and 5. So this value is 1. So it is taking the value from 1 to 5. So range of Gx is 1 less than equals to x less than equals to 5 for G inverse x. As you can see, so this is basically 1, 5 close interval there, because it is touching the value of it is touching at the particular points 1 and 5. That's why. So the range is 1 and 5. Here it is touching, and also here it is touching there. So that's why domain of G inverse x will be 1, 5. So write down the domain of G inverse x. It is 1, 5. So this problem is also done. Now the find an expression for G inverse x. We will do this problem. Find the expression of G inverse x. So to do this problem, basically y is equals to 4 cos x plus 1. So to do the inverse, the x and y values will be interchanged. So x will be 4. So x will be 4 cos y. X will be 4 cos y plus 1. We are just doing this to get the value in terms of y. To get the inverse function in terms of y, we are doing this particular change. Now the thing is, x minus 1 equals to 4 cos y. So 4 cos y is equals to x minus 1. So cos y is equals to x minus 1 divided by 4. So y equals to cos inverse x minus y divided by 4. So this is the inverse function. So G inverse y equals to G inverse of x, as the independent variable is x in the inverse function. That's why we have done the change, and in this way the independent variable is still x. So G inverse x, it is equals to nothing but cos inverse x minus 1 divided by 4. So this is the find an expression for G inverse X. So this is the expression for G inverse X. Now we will move towards the next question, that is, consider the following system of equations where A belongs to R, and these are the system of equation. Now first problem is find the value of A for which the system of equation does not have a unique solution. So this is the first question. So we will do the question, but before doing the question, I am just changing the first equation here. So we will do from row reduction matrix. So before writing down the matrix, I am just taking this first equation in this particular position. Why I am taking this, you will understand whenever I am doing this particular problem. So ultimately the matrix will be, if I take the first equation at the third position, then this will be my first equation, this will be my second equation, and this will be my third equation. Just note this particular thing. So if this is the first equation, then the matrix will be 1, 2, A, and here is the line, and after that the values of this particular equation will be there. So it is 5. Then we have the second equation to be 5, 12. So 5, 12, and here the value of Z is 0. So 0, and here for this particular equation the value is 2A. And as this is our third equation in this particular term, so we are writing down 2, 2, oh, no variable will be there. So 2, 4, and minus 1. So here the value will be 2, 4, minus 1. Here the value will be 10. So in this way we have changed the matrix. Now just we need to do the row reduction, and I am doing the row reduction. 2 row reduction I will be doing this in a same matrix, just to save the time and space. So just try to understand this particular fact. This is the main part of this particular question. So we are doing row reduction. Okay, so here the values are 5, 2A, and 10. First row reduction, see the first row reduction, that is R2, row 2. We are changing the row to R2 minus 5R1. To make this particular value 0, we are transforming this equation from R2 minus 5R1. So if we do this row reduction, then we have in our hand 1, 2A, the first value is same. Now R2 minus 5R1, so this particular value will be 0. Then 12 minus 5 into 2, that is 10, that is 2. Here it will be 2, and 0 minus 5A. So it is basically minus 5A. And again one line is there, here it is 5, no change there. And for the second it is R2 minus 5R1, so 2A minus 25. So 2A minus 25 we are getting. And for the third case, again we are doing one row reduction here, and I am doing 2 row reduction in one particular transformation to save the time and space. Here it is 2, so just see the transformation, that is row 3 equals to R3 minus 2R1. So we are doing this reduction, R3 minus 2R1, to make this particular row 0. So R3 minus 2R1, so 2 minus 2 equals to 0. Here 4 minus 2R1, 2 into 2 equals to 0. So here it is again 0. And minus 1 minus 2A is equals to, here will be 10 minus 10 equals to 0. So we are getting this particular thing. So we are getting this particular matrix. Now the thing is, see here in your syllabus or in your book also you will find this particular thing. So if H and I is there and other values are 0 for a particular matrix there, and above the other values are there, so obviously H, Z will be equals to I. So Z equals to I by H. Here I is one number, just one number, not any imaginary number. Just don't get confused. I am just taking the numeric, like these are written in your particular book. That's why I am taking this thing. So here H will be any non-zero value. So that's why I have taken this. So from here I can see, from here I can write that minus 1 minus 2A is equals to 0, because this particular coefficient will be 0. So ultimately the thing is minus 1 minus 2A into Z equals to 0. So ultimately the value of Z is 0. That's why this is happening. So minus 1 minus 2 equals to 0. So in this way we can take minus 1 equals to 2A. So A equals to minus half. So for this particular value, the complete set of equation will not have any unique solution. The system of equation will not have any unique solution if the value of A is minus of. I think till this you have understood this particular problem. It is a very easy problem. Just you need to reduce the matrix in the row format, and after reducing, just it is very simple. It is also in your syllabus to do this problem in this way. So basically we need to sum up the variables here. So the variables for this particular column is X, variable for this column is Y, and variable for this particular column is Z. So in this way, this into Z will be equals to 0. So that's why we have done A for the value of A equals to minus of, the system of equation will not have any unique solution. Now the thing is, find the solution of the system of equation when A is equals to 2. As we have known, for A equals to minus of, the system will not have any unique solution, but here the value of A is equals to 2. That's why for A equals to 2, the system of equation will have obviously the unique solution. So let's solve this. Now find the solution of the system of equation when A is equals to 2. The same thing that we have done, the reduced matrix, we are just putting this. So the reduced matrix was 1, 2, 2, 1 to the reduced matrix we have done, that was 1 to A, 0 to minus 5A, and it was 0, 0, minus 1, minus 2A, and here the values was 5, 2A minus 25 and 0. But after putting the values of A, now here as you can see the value of A is 2. So in this particular sections, A, then 5A, 2A, 2A minus 25, we are giving the values. So after putting the values of A equals to 2, this particular values will be, here the values will be here A equals to 2, so this is 2, and it is minus 10, it is minus 5, it is minus 21. So the values are given here, and the variables are X, Y and Z for this particular columns. Now from here it is very easy to calculate, like I have already mentioned. So minus 5Z, here X into 0, Y into 0, so minus 5 into Z is equals to 0, so Z is becoming 0. So the first value is found out. Now the second case, in the second equation, as you can see, that is 0 into X plus 2 into Y minus 10 into Z is equals to minus 21. So here 2Y, as you can see, 2Y equals to minus 21, because Z is also 0, so it is 0 and it is also 0. So Y equals to minus 21 by 2. So Y value is also there. Now we need to find out the value of X from this particular row. So here X into 1, that is X plus 2Y plus 2Z is equals to 5. Now we are putting down the value, so this will be 0 because the value of Z is 0. So X plus 2 into minus 21 divided by 2 is equals to 5. So 2 cancelled out. So X minus 21 equals to 5. So X equals to 26. So this is the value of the equation. So find the solution. So X will be 26, Y will be minus 21 by 2 and Z will be 0. So basically it is nothing but X is equals to 26, Y equals to minus 21 by 2 and Z equals to 0. So this is the answer. So find the solution of the system of equations when A equals to 2. The solution will be X equals to 26, Y equals to minus 21 by 2, Z equals to 0. You can also like reduce this particular thing in decimal format, but that is not necessary. So in this way this problem is also done. So thank you for watching IB360. In next videos we will discuss the later problems. Thank you. So the fifth problem is, the vectors A and B are defined by, A is defined by these 3 dimensions and B is defined by these 3 dimensions, where T is in R. Find and simplify an expression for A dot B in terms of T. So first of all, how we will calculate A dot B? A small theoretical part. If A vector is equals to like I plus 2j plus 3k, so these are the dimensions of the unit vector along the x, y and z axis, and this particular thing can be written in this format, that is 1, 2, 3. So these are basically the same thing, x, y and z axis values, where I, j and k cap are the unit vectors along those particular axes. And b vector, say b vector equals to again I, same, plus 2j plus 3k. So again we can write b in this way. This is just one example. So if we do a vector dot b vector, then we just need to multiply all these things. And for rule for multiplication is I dot I is equals to 1, I dot I is equals to 1, j dot j equals to 1, and k dot k equals to 1. So from here you can obviously see just we need to multiply all the coefficients only. So 1 plus 4 plus 9. So this will be the only thing, because I into I equals to 1, j into j equals to 4, and k into k equals to 9. This is just one example. And one more thing, just now we can find out the answer. So in this way a dot b, or the dot product of any vector, is calculated. So this was just one example to give this fact only. Now we will move towards this problem. So A is given as 1, 1 t, and B is given as 0, minus t, and 4 t. So just we need to multiply only this with this, 1 with minus t and t with 4 t. So now A dot B becomes a vector. This is a vector sign. A dot B becomes 1 into 0 plus 1 into minus t plus t into 4t. So we are getting the answer to be 0 minus t plus 4t square. So if we arrange the answer in a perfect order, then we get 4t square minus t. So ultimately a vector dot b vector is equals to nothing but 4t square minus t. So this is the answer. So in terms of t, we have calculated the answer. Now we will move towards the second part of this problem. Hence or otherwise, find the values of t for which the angle between A and B is obtuse. This thing is very important. The angle between these two vectors is obtuse. Now just see one theoretical part, that is, we know that this is all, this is sine, this is tan, and this is cos. For these four quadrants, if the angle value, if the angle is theta, so according to the theta in which quadrant the value will be positive or negative, we know that. Now we are concerned about the value of cos, because we know that a dot b, a vector dot b vector, is equals to mod of a mod of b into cos theta, mod of a dot mod of b into cos theta. So we are concerning about the value of cos theta. So cos theta is in this fourth quadrant. Now obtuse angle lies between 90 degree and 180 degree. So obtuse angle in this quadrant. So obviously in this particular quadrant, all cos values will be negative. So that's why we can write that cos theta will be less than 0. Cos theta is negative. To be A and B, for the angle to be obtuse, for the angle to be obtuse, cos theta will be less than 0. Now the most important thing is, because it is not one, for first point, it is not the quadrant of cos, that's why it is negative, and for obtuse angle also the cos is negative. Now the thing is, cos theta is negative. Now see this particular equation, just see this equation. Here we have written one formula, that is a dot b is equals to mod a into mod b into cos theta. Now mod a into mod b, these two will be positive and cos theta is negative. That's why the complete multiplication will be negative. That's why we can write a vector dot b vector will be less than 0 if cos theta is less than 0. So if cos theta is less than 0, the complete product will be less than 0. This is obvious, because if cos theta is less than 0 and we have taken mod of a and mod of b just to get the value, these values will be positive. That's why a and b, if for the vectors a and b, the multiplication of these two vectors in dot product will be negative. Now in previous slide you can see we have found out this value to be 4t square minus t. So we can write from here we can write 4t square minus t is less than 0. So basically you can say this is one quadratic equation that we can keep in inequality part. So first we will solve the quadratic equation, and after that we will apply the inequality, because it will give us the perfect result. So from here we are getting t common. So 4t minus t is less than 0. So basically the thing is, we need to first calculate this equation from quadratic equation part, and after that we will apply the inequality. So if we apply the quadratic equation in this particular thing, then we can write t into 4t minus 1, t into 4t minus 1, here it will be 1, t into 40 minus 1 is equals to 0. So we can write t equals to 0 and t equals to 1 by 4. So these two values we can get. One value is t equals to 0 and another value is t equals to 1 by 4. So as you can see, this is one quadratic equation. So we can also draw the graph of this equation. So I am drawing the graph with my free hand. So please pardon me for that. So this is the value where this is the t axis. So this is the value where t equals to 0. And let us assume this is the value where t equals to 1 by 4. So we can draw one quadratic equation which is passing the values from 0 to 1 by 4, and you can see for this particular region, the value of y is negative. The value of y is negative. So in this way, a dot b is negative when the value of t is in between 0 and 1 by 4. This is very important part. You need to understand. When the value of t is in between 0 and 1 by 4, the value of y is negative. So what is the value of y here? This is y axis. So this is basically nothing but a vector dot b vector. So basically it is 4t square minus t. So 4t square minus t will be negative when the value of t is in between 0 and 1 by 4. So in this way, we can write from this equation now, that is the value of t is in between 0 and 1 by 4. So hence or otherwise find the values of t for which the angle between a and b is obtuse. So the value of t will be 0 less than t less than 1 by 4. Now one most important thing, why we have not taken equal to sign in this particular inequality, because at 0 the value of the function is 0. At 1 by 4 the value of the function is 0, and 0 is not one negative. 0 is not the negative number. That's why we have taken from 0 to 1 by 4 in open interval. Okay. So in this way, this problem is also done. Now we will move towards the next problem. This problem, use mathematical induction to prove that summation r equals to 1 to n r of r factorial is equals to n plus 1 factorial minus 1 for n belongs to z plus. Now the thing is, for induction we have three steps. First step 1, proof against n equals to 1. The theoretical part is very important. If you understand this particular part, then the problem is easy for you. Now second step is step 2, induction hypothesis. Induction hypothesis, where we assume for n equals to k, the proof is true. Now the third step is induction. This step is called induction step. So in induction step we need to prove for n equals to k plus 1, the proof is right. So these are the three steps that we need to follow. The first step is proof against n equals to 1. Second step is induction hypothesis. This particular step is called induction hypothesis, and in this particular step we need to assume for n equals to k the particular proof is correct. And the third step is called induction step, and in this step we need to prove for n equals to k plus 1 the proof will be right. So after all these things, if for n equals to k plus 1 also the proof is right, then we can say that the LHS equals to RHS proved. Okay, so the first step, now we will move towards the first step. This is the first step, that is step 1. So for step 1, n will be 1. So for n equals to 1, we have summation. Here you can see the actual equation. So summation r equals to 1 to 1, r equals to 1 to 1, r of r factorial is equals to 1 into 1 factorial is equals to 1. So we can write 1 plus 1 factorial minus 1. This is also same, because we need to prove, we need to write in this particular format, that is n plus 1 factorial. Now you can see the value of this is 1, and 1 plus 1 factorial is basically 2 factorial. So value of 2 factorial is 2 minus 1 equals to 1. So in this way these two steps are same. So step 1 is satisfied. So step 1 is satisfied. Now step 2. Please see please see that this step is very important. We just assuming the part, that is induction step. This is the induction hypothesis step. So induction hypothesis. Now the most important thing is, in induction hypothesis step we need to assume. So let us write assume and whatever I am writing excluding the steps, you need to write in this particular way to get the full marks from these induction problems, because step 1 is important and you need to clarify which one is step 1. Then you need to clarify which one is step 2. That what I am doing, step by step you need to follow. Then induction hypothesis. So assume pk is true, p of k is true for some k greater than equal to 1. Because why there is a equal to sign for inequality? Because for k equals to 1 we have proved that particular part. Now what is k? K is any arbitrary value of n. So assume pk is true for some k greater than equals to 1. So if k is true, then we can obviously write summation r equals to 1 to k, because the limit is from 1 to k, that is k is greater than equals to 1. So the minimum value of k will be 1. So that's why r is equals to from 1 to k, r of r factorial is equals to, because we are assuming this particular part to be true, so we can obviously write from here, that is k plus 1 factorial minus 1. So we are getting this answer. And how we are getting this answer? Just from the hypothesis that we are assuming this is to be true. So assume pk is true for some k is greater than equals to 1, where the minimum value of k is 1 and the value of k will go up to k. So summation r equals to 1 to k, r of r factorial is equals to k plus 1 factorial minus 1. So this step is done. So I think till now it is clear for you. Now we need to go towards the step 3, where we need to prove for k plus 1 also the induction hypothesis is true. And for if k plus 1 also the induction hypothesis is true, then the mathematical induction is correct. And for k plus 1 if it is not true, then the mathematical induction is not correct. And the thing is LHS will not be equals to RHS. But for our question it is written that the LHS equals to RHS. So it is obvious that if we use for k plus 1th term, this will be correct. So let us do this part. It is a very important part, that is step 3. So step 3 is called the induction step. So induction step. So in induction step we are taking, we need to show p of k plus 1 is also true. So if p of k plus 1 is true, then the limit will be from summation r equals to 1 to k plus 1. Because in previous slide you can see that the summation was from 1 to k, but now we need to find out the induction for the k plus 1th term. So r equals to 1 to k plus 1, r of r factorial is equals to, we can write k plus 1 into k plus 1 factorial plus k plus 1 into k plus 1 factorial plus the proof for the kth term, that is r equals to 1 to k r of r factorial. This is the proof for the our kth term was, that was this step is from induction hypothesis. This step is from induction hypothesis. This particular part is already written in the step 2, that is induction hypothesis. So this complete equation is true now. Now we can write k plus 1 into k plus 1 factorial plus this part will be that we have proved earlier, k plus 1 factorial minus 1, just from the induction hypothesis step. Again I am saying this particular step is from induction hypothesis step. So now we can take k plus 1 factorial in common, then we will have k plus 1 into k plus 1 factorial minus 1. So we can write k plus 2 into k plus 1 factorial minus 1. Now the thing is, n plus 2 into n plus 1 factorial is basically nothing but n plus 2 factorial, or this is just an example, n into n minus 1 factorial in this particular way. So n minus 1 factorial is there and the next time is n. So it is basically nothing but n factorial. So in this way, this factorial formula you also need to know. Otherwise, you will not be able to do the induction problems. For many cases, for many functions, you need to do all this calculation. So n plus 2 into n plus 1 factorial. This is the previous term factorial. This is the previous term factorial, and we are just multiplying this particular part. Also, you can see the example, that is 3 factorial into 4 is basically nothing but 4 factorial. So this is the part. 3 factorial into 3 plus 1 factorial is basically nothing but 3 factorial into 3 plus 1 is basically nothing but 4 factorial. So in this way, we have calculated this part. So from here we can write it is basically nothing but k plus 2 factorial minus 1. We can write this k plus 2 factorial minus 1. Now we can write this in this particular way, that is k plus 1 factorial minus 1. Just see the part. Here it must be n plus 1 factorial minus 1, and we have taken n equals to k plus 1, and see the complete thing is here, that is k plus 1 factorial minus 1. We can assume it to be n plus 1 factorial minus 1. So this part is done. So obviously for k plus 1th term also this particular equation is true. So we can conclude, hence P of k plus 1 is true. We can conclude this part. So now the conclusion. The conclusion is very important. You need to write it. If P of 1 is true and P of k plus 1 is true, P of k plus 1 is true, when assuming P of k is true, because we have assumed P of k is equals to true, and after that we have proved P of k plus 1 equals to true. So this is the line. Then P of n is true for all n belongs to Z plus. So in this way this problem is done. So the mathematical induction is proved. So it is proved. So in this way, in step by step, you need to calculate all these things. Thank you for watching IB 360. In next video, we will discuss the later problems. Thank you.
So here the question is, consider the curves C1 and C2 defined as follows. That is, C1 is xy equals to 4 where x is greater than 0, and C2 is y square minus x square is equals to 2 where x is greater than 0. Now, using implicit differentiation or otherwise, find dy dx for each curve in terms of x and y. So for the first thing, C1 is equals to xy is equals to 4 where x is greater than 0. So now we will differentiate in both the sides because it is one implicit differentiation. So ddx of xy is equals to ddx of 4. Now the rule that we need to apply here is the multiplication rule, that is ddx of uv where u and v both are the functions of relation with x, then it becomes u dv dx plus v dv v du dx, u dv dx and v du dx, v du dx. So this is the part. Now the thing is, as it is done here, so the same formula we will apply here, then we will get ddx after applying here. So it will be x, that is y ddx of x plus x ddx of y is equals to ddx of any constant term is equals to 0. So from here we are getting, that is y, as you can see it is very clear, that is y plus here it will be x dy dx, because y itself is the function, is equals to 0. So we are getting dy dx is equals to minus y by x. So this is for the first case, that is dy dx equals to minus y by x. This is the first for C1. For C1. Now for C2 we will do here. For C2, let's do this problem. So C2 is equals to y square minus x square is equals to 2, where x is greater than 0. So we are getting ddx of y square minus x square is equals to ddx of 2. So we are getting, now just divide the part, ddx of y square minus ddx of x square is equals to 0, because constant term will become 0. Now the thing is, see here we will do the chain part, that is ddy of y square into, see here whatever I am doing, that is here we are using the chain rule to do this particular differentiation. So we are taking u is equals to y square. So dd u of u into d, here just see ddu of u, that will be 2u into du dx. So that's why dy dx. So ultimately we will get 2y dy dx, because it is in function of y. So that's why we are getting, this is just one derivation part. So we are getting 2y dy dx. Here just see 2y dy dx. So u is basically just equals to y. So that's why we are getting this answer. So it will be y square ddu of y square, that is 2y dy dx. So this will be the answer of this particular differentiation if we elaborate that. So 2y dy dx minus 2x equals to 0. So from here we are getting dy dx to be x by y. So this is the fact for this. So from here we can write here dy dx equals to minus y by x, and here dy dx equals to x by y. So in this way this problem is done. The first part is done. Now we will move towards the second part, and please remember the differentiation of the two functions. Here it is minus y by x, and here it is x by y. So now the second problem. So here the dy dx was, it was minus y by x. For C1 the dy dx was minus y by x, and for C2 the dy dx was x by y. Now the second problem, show that the tangents to C1 at P is perpendicular to the tangents to C2 at P. So let the coordinate of P is a comma B. So this is the coordinate of P, a comma B. Now both the curves here, as you can see here, P a comma B is given. So in this way it is given. Now so here we can write y is equals to B and x is equals to A according to the coordinate rule. Now from this particular principle we can write the slope of the tangent to C1 at PA comma B, as you can see the slope of C1 was minus y by x, so it will be minus b by a. And in the same way we can write the slope of the tangent to C2 at P A comma B, this is equals to x by y, so it will be a by b. And from the rule we know that for two tangents, if two tangents are there, m1 and m2, then the condition for perpendicular, it is m1 into m2 is equals to minus 1. So if this is the relation, then the two tangents will be perpendicular. So from here we can write m1 is equals to minus b by a and m2 equals to a by b. So we can check m1 into m2 is equals to minus b by a into a by b is equals to minus 1. So m1 into m2 is equals to minus 1. So the multiplication of the slopes of the tangents is equals to minus 1. It means they are perpendicular to each other. The tangents are perpendicular to each other. Using the formula, we have proved that. So show that the tangent to C1 at P is perpendicular to the tangent to C2 at P. So as this is the relation m1 into m2 equals to minus 1, so this is proved. Now the next problem. Here the next problem is, consider the equation z to the power 4 plus az cube plus bz square plus cz plus d equals to 0, where a, b, c, d belongs to R and z belongs to C. And here two roots are given. So R1 is equals to log base to 6 and R2 is equals to I root 3. So if any complex root is given, then obviously the opposite complex number will again be the another root. So R3 is equals to minus 1 root 3, because here it was plus I root 3, so that's why R3 will be minus I root 3. And now R4 we need to determine. So from here, as you can see, the sum of all roots is given. So as the sum of all roots it is given, so from here we can find out the fourth root. So from here we can write log base to 6 plus I root 3 minus I root 3 plus R4 is equals to plus R4 is equals to the addition of the roots are 3 plus log base to 3. So from here we can write, we are cancelling out this. So R4 is equals to 3 plus log base to 3 minus log base to 6. So from here easily we can write, here it is log base to 6 minus log base to 3. So it is having a simple formula, that is log base to 6 by 3, because it is in subtraction, so in logarithm it will be in division format. So 3 minus log base to log 2 base 2. So the formula of this is 1. So 3 minus 1 equals to 2. So R4 is nothing but R4 is equals to 2. So for this particular equation where the degree is 4, we have 4 roots in our hand. Now the thing is, we need to show 6a plus d plus 12 is equals to 0. To do this problem, we will do it in two ways. The first one is to find out the sum of the products. And the formula is, for this particular problem, sum of the products, it is minus a by 1. So minus a, the coefficient of z to the power 3, divided by coefficient of z to the power 4. So it is coming out to be minus a by 1. And now we need to find out the product of the sum of the, here it will be roots, sum of the roots and product of the roots. So for product of the roots, it is minus 1 to the power 4, the degree. Here the degree is equals to 4. The formula is minus 1 to the power 4 into the constant term d divided by the coefficient of z to the power 4. So coefficient is 1. So ultimately it is becoming d. So product of the root is equals to d and sum of the roots is equals to minus a. You just need to remember this. Okay, so in next slide we will solve this problem. So sum of the roots, sum of roots is equals to minus a, and product of roots is equals to d. So now we will find out the values of a and d. So sum of the roots minus a is equals to, sum is given, that is 3 plus log base to 3. So a is equals to minus of 3 plus log base to 3. So the value of a we have found out. Now we need to find out the value of d. So for that, it is basically product of the roots. So now we need to do the product of the roots. So the roots are, already we have done the roots, that is minus I by root 3, I by I root 3, then 2, then another root is log 2 6. So multiplication of all this we will do. So minus I root 3, then I root 3 into 2 into log base to 6. So if we do the product, it will be minus I square into 3 into 2 into log 6 base 2. So it is basically equals to d, because the product of the roots is equals to d. So minus I square equals to minus 1. So minus I square will be 1. So it is 6 log base to 6 is equals to d. So the value of d is also there. So after finding out the values of a and d, we will calculate this biggest equation, that is 6a plus d plus 12. So you'll put the values here, that is 6 into the value of a is here, as it is minus here, so we are doing minus here. So minus 6 into 3 plus log base to 3 plus the value of d is 6 log base to 6 plus the value is 12. So from here we are getting minus 18 minus 6 log 3 base 2 plus 6 log 6 base 2 plus 12. So from here we are getting minus 6, and from here we can take this is like this, so plus, we are taking plus, so this value will be in the front. So again we are taking common 6 because it is common in both the logarithmic terms. So we are taking common 6, so 6 then log base to 6 minus log base to 3. So we are getting minus 6 plus 6 into log 2. Here it is very easy because it will be 6 by 3. So minus 6 plus 6 into log 2 base 2. So the value of this is 1. So 6 plus 6 is basically equals to 0. So it is proved. So in this way this problem is done. It was a bit tricky question, and the trick was here, that is one root is I root 3, so the another root will be minus I root 3 according to the rules of the complex roots. So in this way this problem is done. Thank you for watching IB360. In next videos we will solve the later problems, and thank you. Now a ninth problem of this particular paper. So the problem is, consider a triangle OAB such that O has coordinate 0 0 0, A has coordinate 0 1 2, and B has coordinate 2B, 0, B minus 1, and where B is less than 0. Now find in terms of B a Cartesian equation of the plane containing this triangle. So first of all, this must be the normal equation. So that's why the thing that we need to remember, that if this is I am drawing in freehand, so please forgive the minute differences. So the thing is, if this is one line and we have another line OC here, so if you just see, if this is the triangle properties, then OA, and here we have B. So just see the triangle properties only. So here the coordinates for O is 0, 0, 0, and for coordinate properties for A are 0, 1, 2, and for B it is 2B, 0, B minus 1. So this is just vector property, and if you consider this point to be vector points, then you can easily calculate the distance, or otherwise also you can calculate the distance, but just I am giving you the example. So basically, to do this problem, we need to first calculate the distances first. So OA, it is basically nothing but A minus O, and for that you will find the answer to be 0, 1, 2 minus 0, 0, 0. So ultimately it is coming out to be 0, 1, 2. So remember, OA is equals to 0, 1, 2. And obviously this will be the coordinate for x, this will be the coordinate for y, and this will be coordinate for z. For all the terms in 3D geometry, the configuration is like this: x, y, z. So please keep this in mind. So x, y, z, 0, 1, 2 for OA. And for OB, again we need to determine from B minus O, and the coordinates for B are defined as 2b, 0, b minus 1 minus 0, 0, 0. So ultimately it is coming out to be 2b, 0, b minus 1. And one more thing, just remember, if we try to get the positional value of any point with respect to the origin, then the positional value is just the value. So ultimately we are trying to find out OB, basically the distance from the origin. So ultimately the value of the point will be the distance. So OB is equals to 2b, 0, b minus 1. Now what we need to do, we just, the normal is parallel to the vector product. So now the normal is parallel to the vector product. This is very important. This is very important. The normal of this particular triangle. So if we construct the triangle particularly, so if you construct the triangle, so ultimately, so if you construct the triangle from this point to this point, so ultimately you will find for OAB triangle, if the normal we are trying to calculate from OA and OB, it is basically just the vector multiplication of the product. So that's why I have previously I have also said, for points we can consider them to be in vector also, because here the plane concept is also there. So obviously we can take the vector concept here also. So ultimately what we need to do, we need to find out OA cross OB, because the normal is the parallel to the vector product. So in next slide we will do the vector product. So OA cross OB. So to find the vector product we need multiplication I, J and K. So here I am writing OA was OA, this was 0, 1, 2, and OB, this was 2b, 0, b minus 1. Just we need to put the values here: 0, 1, 2. Here it is 2b, 0, b minus 1. So just now normal determinant. So I, this is just the unit vectors along way OA and OB. Basically I represents the unit vector towards x-axis, J represents the unit vector towards y-axis, and K represents the unit vector towards z-axis. Now the thing is, if here is I, then cross multiplication will be vector according to vector multiplication. This row and this column including I will be excluded. So ultimately this cofactor we need to determine. So 1 into b minus 1, that is b minus 1, minus 2 into 0, that is 0. So ultimately we are deducting that. Then minus j, the determinant expansion is very important whenever you are trying to do any cross multiplication or some other products also there out there. So please first know how the determinant calculation is done, then you will understand all these processes. So minus j here, minus j into 0 into b minus 1, so ultimately 0 minus 2 into 2b, that is 4b, then plus k cap, then 0 into 0, then minus 2b, 0 into 0 minus 2b, so ultimately 0 minus 2b. So we are getting 2, this is to be b minus 1 I cap plus 4b j cap minus 2b k cap. Now we need to find out in the Cartesian equation in terms of x, y, z. These are the terms in related with Cartesian coordinates. So ultimately we can represent this with Cartesian coordinates also, x, y and z, because already I have told that along x-axis the unit vector is I, along y-axis the along y-axis the unit vector is j, and along z-axis the unit vector is k. So ultimately we are getting this result in Cartesian. In Cartesian we get b minus 1x plus 4by minus 2bz. So ultimately find in terms of b a Cartesian equation of the plane normal to the containing this triangle. So ultimately this is our answer. So this will be the equation of the plane. Now one more thing, as this is a very important point, note that this is a very important point. So as 0 comma 0 comma 0 is on the plane, is on the plane, is so d value will be 0. So basically d is nothing but the constant value for the plane. So this value will be 0. That's why the equation doesn't contain any constant term that a plane requires. But at this moment, as the origin is inside the plane, that's why the d term will be vanished. So that's why this is the thing. So now we will move towards the next problem. This is again a very simple problem. So let M be the midpoint of the line segment OB. So what was OB? OB was 2B, comma 0, comma B minus 1. Just assume this particular part, if it is OB and this is the midpoint M, so what will be the coordinate of the midpoint M? So ultimately M will be half the coordinate of OB. So ultimately it will be 2b by 2 comma 2b, like the equation is 0 plus, let me elaborate the complete process, then you will understand each and every fact. So here it is 0 comma 0 comma 0 and it is 2b comma 0 comma b minus 1. So now we are trying to find out the coordinate of M. So coordinate of M is 0 plus 2b divided by 2 comma 0 plus 0 divided by 2 comma b minus 1 plus 0 divided by 2. So ultimately the coordinate of M we are getting to be, that is 2b by 2 comma 0 comma b minus 1 divided by 2. So ultimately it is b comma 0 comma b minus 1 divided by 2. So this is the equation, this is the coordinates of the point M, that is the midpoint of the line OB. Now the thing is, find in let M be the midpoint of the line segment OB. So the Cartesian coordinates of M are there. Now find in terms of B the equation of the line L which is passing through M and is perpendicular to the plane. So in the previous slide you have the equation that is perpendicular to the plane. So if we think the let the line is L, so it is basically M, the midpoint, plus lambda n, where n is the normal. So n was already, we have determined n, and it was that the Cartesian coordinates are b minus 1 comma 4b comma minus 2b. Already we have found out this particular normal equation in the previous slide. Just see the slide and you will understand this fact. So ultimately this will be the equation of the line, because M is the line is passing through M and is perpendicular to the plane. So ultimately perpendicular to the plane, so it will be parallel. So ultimately parallel to this particular line. So M, the coordinate of M are b comma 0 comma b comma 0 comma b minus 1. So b comma 0 comma b minus 1 divided by 2 plus lambda into the coordinate of n are b minus 1 comma 4b comma minus 2b. So ultimately this is the answer of the plane. So the plane is, here it is M coordinates b comma 0 comma b minus 1 divided by 2, just a compiled answer b minus 1 comma 4b comma minus 2b. So this is the equation. And one more thing, you can also write this equation in terms of vector also, then you need to multiple there. ijk unit vectors also. So the second problem is also done because we need to find out this problem with respect to B. So that's why this problem is done. Now we will move towards the third problem of this question. So show that L does not intersect the y-axis for any negative value of B. So for this question, let us assume it intersects the y-axis. Let us assume L intersect the y-axis. Now if anything is intersecting the y-axis, it means at that particular point x value is 0 and z value is 0. So ultimately the equation of the line L, the equation of the line was we have already found out that b comma 0 comma b minus 1 divided by 2 plus lambda into b minus 1 comma 4b comma minus 2b. So this was the equation of the line L. Now we are assuming that line L is intersecting the y-axis. So at that particular point x value is 0 as well as y value is 0. So if we do that, so x value is 0. So if x value is 0, then ultimately we are getting b plus lambda of b minus 1 is equals to 0 at x equals to 0. So we are getting at x equals to 0, b plus lambda into b minus 1 equals to 0. So we are getting lambda value is equals to minus of b by b minus 1. Again at z equals to 0, we are getting, if we put z equals to 0, then b minus 1 divided by 2 plus lambda into here minus 2b is equals to 0. So we have the lambda value. So ultimately just see this equation. This is the equation number 1 and this is equation number 2. So from equation number 1 and 2 we get, ultimately we are getting b minus 1 divided by 2 plus the value of lambda is minus b by b minus 1 into minus 2b is equals to 0. So ultimately we are getting b minus 1 divided by 2, here minus minus plus, so ultimately plus 4b square divided by b minus 1 is equals to it will be 2b square. So it is 2b square, this part, this is 2b square. So 2b square divided by b minus 1 is equals to 0. So we are getting b minus 1 whole square, just cross multiplication, or let me do it in detail part. So b minus 1 divided by 2 is equals to minus 2b square divided by b minus 1. So we are getting b minus 1 whole square equals to minus 4b square. See this part, b minus 1 whole square will give the positive thing now, and 4b square, this is also will give the positive part. So this is positive, this is positive, and this part is also positive. So ultimately this cannot possible because here the minus sign is here. As you can see, the minus sign is here. So ultimately this is not possible. So this is wrong. Now what we have approached? We have approached that let us assume L intersecting the y-axis. So ultimately this assumption is wrong. So that's why L does not intersect y-axis for any negative value of b. So as you can see, for any negative value of b, we are getting the wrong assumption. That's why this part is not possible. So in this way, the last problem is also done. Thank you for watching IB360. In next video, the rest of problems will be done. Thank you. The problem is from integration, and it is use integration by parts to show that e to the power x cos 2x dx is equals to 2 e to the power x by 5 sin 2x plus e to the power x by 5 cos 2x plus c. So this we need to prove. But the thing is, first you need to know the formula for biparts, for integration bipart, and the simple formula is uv is equals to uv dx integration uv dx, it is equals to u integration v dx minus integration du dx, integration du dx, then integration v dx, and this is whole dx. So this is a bit complicated formula, but if you know how to solve the problem, and if you have solved one or two problem, then it will be bit easier for you. So integration uv dx is equals to u integration v dx minus integration of du dx and multiplication of integration of v dx and complete dx. So you will do that. Let us consider u to be e to the power x and v to be cos 2x. So this we have considered here. Now we will start to solve the problem. So the part here will be it is, so I equals to, let us consider I. So I is equals to integration e to the power x cos 2x dx. So first step, this step is very important. We have considered u is equals to e to the power x and v is equals to cos 2x. So it will be e to the power x integration cos 2x dx minus integration, now here I am doing d dx of e to the power x equals to e to the power x. So as you can see, this complete is e to the power x. So d dx of e to the power x is e to the power x. So we will use that property here. So if you apply that property here, then we have now the second part. Here it will be e to the power x and just say simple bracket and the problem will be done. So here d dx of from here see u is equals to e to the power x. So du dx will be e to the power x. Directly I am writing integration v dx. So v is cos 2x. So cos 2x dx and whole dx. So this will be the answer. Now we need to calculate this. So here it will be e to the power x and integration of cos 2x is equals to sine 2x by 2. This is just by practice you can know all these things, and it will be e to the power x of minus here it will be again sine 2x, so sine 2x by 2 dx. So it is sine 2x by 2 dx. So we are getting e to the power x sine 2x whole divided by 2 minus integration minus half of e to the power x sine 2x dx. So see the fact, we have started with e to the power x cos 2x dx. Now we have e to the power x sine 2x dx. So again we need to do this particular problem in bipart. So if you again divide it in bipart, so let us consider again u is equals to e to the power x and here v is equals to sine 2x. So this part again we are considering, that is u is equals to e to the power x and v is equals to sine 2x. So again we are considering this part, and now if we try to do this particular problem again in bipart, so then the formula will be e to the power x sine 2x divided by 2 minus, here it is half and we are using one third bracket because the complete part will be inside the bipart method, so that's why we are using the third bracket. So here it will be just the same formula, u integration v dx. So e to the power x integration sine 2x dx minus integration, now again du dx is equals to, again it will be e to the power x. So e to the power x, then it is in first bracket e to the power x integration sine 2x dx whole integration dx. So this will be the new integration bipart that we need to implement. So please see the next slide to understand this, and we will try to figure out the answer. So after this particular method, if you solve this process, then it will come out to be e to the power x sine 2x divided by 2 minus the step was half e to the power x integration sine 2x dx minus integration e to the power x integration sine 2x dx whole dx. So this was the part. So if you solve this process, it will come out to be e to the power x sine 2x divided by 2 minus half. Now integration of sine 2x is minus cos 2x divided by 2. So ultimately it will be minus e to the power x cos 2x divided by 2 minus, here it is ddx, it was same like e to the power x, and here it will be minus cos 2x dx. So minus minus, here it will be plus. So ultimately this will be plus and cos 2x divided by 2, and it is now dx. So as you can see here, from here the main part arises, that is we have considered that I is equals to integration e to the power x cos 2x dx. This we have already considered, that is I is equals to integration e to the power x cos 2x dx. Now the same thing we will apply here. So the first part will be same as before, so it is e to the power x sine 2x divided by 2 minus, just we need to multiply all these things, so it will be minus minus plus, and 1 by 2 and 2, that is 4, so e to the power x cos 2x divided by 4, and here it is plus and minus, so minus 1 by 4 into integration e to the power x cos 2x dx. Now just see this part. This part is ultimately I. So we are finding I. So it is I equals to. So it is I equals to. So it is basically I equals to. I is the integration that we have already considered. That is I is equals to integration to the power x cos 2x dx. So ultimately this part again will be I. So we can write I equals to e to the power x sine 2x by 2 plus e to the power x cos 2x by 4 minus 1 by 4i. We can write that, because if we try to integrate that again and again, it will be integrated again and again, because e to the power x, the differentiation of e to the power x will be e to the power x always. So that's why we need to use this particular method. So I is equals to e to the power x sine 2x divided by 2 plus e to the power x cos 2x divided by 4 minus 1 by 4i. Now please see the next slide. So ultimately we have got this equation, that is I equals to e to the power x sine 2x divided by 2 plus e to the power x cos 2x divided by 4 minus I by 4. So ultimately now we can write I plus I by 4 is equals to e to the power x sine 2x divided by 2 plus e to the power x cos 2x divided by 4. And one more thing, we are doing the indefinite integral. As we are doing the indefinite integral, so there must be one constant, the integral constant. Now the thing is, we will add the integral constant at the end. Okay, so we are just doing this integration, and at the end we will add the integration constant, so it will be preferable. And if you want to add integration constant in each and every step, then also you can add the integration constant in each and every step, but it may be somehow complicated, so that's why we are adding integration constant at the end by c. Okay, so now it will be 5 by 4, it will be 5 by 4i is equals to e to the power x sine 2x divided by 2 plus e to the power x cos 2x divided by 4. So I is equals to, I is basically the integration that we need to find out. So I is equals to, now it is 4 by 5 into e to the power x sine 2x divided by 2 plus e to the power x cos 2x divided by 4. So from here we can write the answer to be e to the power x sine 2x divided by 2 plus e to the power x cos 2x divided by, here it will be 2 e to the power x, sorry, here it will be 2 e to the power x. Directly I am multiplying all this. So 2 e to the power x sine 2x divided by 5 plus e to the power x cos 2x divided by 5 plus c. C is the integration constant, it belongs to R. So C is the integration constant. C is equals to integration constant. So in this way, this first problem is done. Now we will move towards the next problem. So in this problem, it is told that hence show that integration e to the power x cos square x dx is equals to e to the power x by 5 sin 2x plus e to the power x by 10 cos 2x plus e to the power x by 2 plus c, where c belongs to R. Now the thing is, here we need to find out this integral using the first answer that we have got. So first we need to calculate some particular thing. Here it is written as cos square x. So the formula for cos square was, it is just we need to find out the formula of cos square or using cos 2x. So previously we had cos 2x, so it is cos 2x is equals to 2 cos square x minus 1, or again we can say 2 cos square x equals to 1 plus cos 2x. So from here we can write cos square x equals to half plus cos 2x divided by 2. So this is we have already found out. Now the fact is we will use this integration. So integration e to the power x cos square x dx, again it will be in integration by part formula, and if first we need to give this particular thing. So e to the power x and cos square x, the value we have found out here, that is half plus cos 2x by 2. So it will be 1 by 2 plus cos 2x divided by 2 and ultimately dx. So we are getting here it is integration half e to the power x dx plus half integration e to the power x cos 2x dx. Now just think the fact that already we have used this particular thing, that is e to the power x cos 2x dx. Already we have calculated that. So just we will use that particular part and we will try to figure out the problem. So it is half e to the power x, so it is basically e to the power x by 2, because the integration of e to the power x is again e to the power x, plus half of this complete part is I, that we have already found out. So this value is I. So we will try to put the value here. So if we put the value here, so it will be e to the power x divided by 2 plus here half, and the value of I that was calculated in the previous slide, you can go to the previous slide and you can see 2 e to the power x sin 2x divided by 5 plus e to the power x cos 2x divided by 5, and the complete integration is plus c. Again we are adding the integration constant at the end, so we are getting half e to the power x plus e to the power x sin 2x divided by 5 plus e to the power x cos 2x divided by 10 plus c. So this is the value of this particular integration. Say we are calling this I1. So this is the value that we have got. So the second problem is also done. The second problem was very easy. Just we need to put the value of the previous integration here. So thus this problem is done. Now the next problem. It is a bit of a complicated problem, but if you know the basic concept, then it will be very easy for you. The function f is defined by fx equals to e to the power x cos square x, where the value of x is varying from 0 to 5. The curve y equals to fx is shown on the following graph, which has local maximum points at a and c. So the local maximum points are on A, this point and this point. So the local maximum points are on A and C, and touches the x-axis at B and D. So at this particular point at B and D, the value of the function becomes 0. At this particular point, the value of the function becomes 0. We will do in the detail the parts, but the thing is, the first question is find the x coordinates of A and C, giving your answer in the term in the form A plus arc tan B. So you need to find out this particular part, and it is very easy part. Now what we need to do, first see the points for any graph. For any graph, the maximum or the minimum points are basically the extreme points. So to find out the extreme points, we need to find out f dash x equals to 0. We have to, the condition for finding the extreme point or the maximum points or the minimum points, the condition is f dash x equals to 0. So here fx equals to, just see from here, f of x equals to e to the power x cos square x. So f dash x is equals to, here the formula we need to apply, it is uv dash equals to uv dash plus vu dash. We need to implement this formula here. So it is very easy, that is e to the power x cos square x. We are doing this problem, e to the power x cos square x plus e to the power x into 2 cos x into minus sin x. So just one more thing, here we needed to implement the chain rule also, because here the function v is equals to cos square x. So as it is cos square x, so again we needed to implement the chain rule here. So after applying all these things, if you find out the derivative, then f dash x will be e to the power x cos square x plus e to the power x 2 cos x into minus sin x. So ultimately we can take common, so e to the power x cos x in common, so cos x minus 2 sin x. So this is the value of f dash x. Now the thing is, we need to find out the extreme points or the maximum points that are a and c. And one more thing also, as it is one positive function, so obviously the minimum value will be 0 for this particular graph. As you can see, it is touching the x-axis also. So that's why here a small problem is given in the graph, because some small minute differences are also given, because it is touching the x-axis, but in this graph you can see it is not touching the x-axis, so it is wrong. It will touch the x-axis, because cos will touch the x-axis also. Now the thing is, here it is not touching, but obviously the value, the minimum value is 0. As you can see, the minimum value is 0 because it is one positive function. So here, from here we can see cos x, and now if f dash x equals to 0, so we can write, so e to the power x cos x into cos x minus 2 sin x is equals to 0. So from here either this part is 0 or this part is 0. Now e to the power x is not 0, because for any value e to the power x is equals to 0 is not defined. So ultimately cos x equals to 0. So now if cos x equals to 0, we are getting these points only, b and d points, because at that particular point, if cos x is 0, the ultimate function will be 0. So that's why these are the points of b and d, or the minimum points, because at this particular point we are getting the minimum values of the function. So ultimately the answer will be cos x minus 2 sin x at this point. Only minimum points we are getting. So cos x minus 2 sin x is equals to 0, because we are left with another option only, cos x minus 2 sin x. So cos x minus 2 sin x equals to 0. So from here we can write cos x equals to 2 sin x, or we can write tan x equals to half. So from here we can write x equals to arc tan half. So the first point we got, x equals to arc tan half, that is this point. So this is the point A x coordinate. And to find out the coordinate of C, what we can do, as we know this particular form, that is, we know that all sine tan cos. So obviously we can get this particular value in this particular quadrant also. So this quadrant is pi plus quadrant. So because this particular part is pi, so ultimately this particular angle will be pi plus the angle. So ultimately again we can write x equals to pi plus arc tan half. This is the point for C, x coordinate. So in this way we have got both the points. The first point is x equals to arctan half, where the value of a will be so here for the first part here a is equals to 0, b is equals to half, and for the second part a equals to pi and b equals to half. So in this way this problem is done. Now we will move towards the last problem. The last problem is the function f is defined by the complete thing is given there, and find the area enclosed by the curve and the x-axis between b and d. So this is b and this is d. So we need to find out the area between b and d. So obviously you can see this part. So the functional value fx is equals to e to the power x cos square x. This will be 0 because at this particular point at b and d e to the power x cos square x will be 0. So e to the power x cannot be 0. So ultimately cos square x is equals to 0. So if cos square x equals to 0 at this particular interval of 0 to 0 less than equals to x less than equals to 5, at this particular interval x can take only values, that is pi by 2 and x equals to 3 pi by 2. So ultimately the values we are getting, this is pi by 2 and this point is 3 pi by 2. And what we needed to calculate? We need to calculate this part, find the area enclosed by the curve and the x-axis between b and d. So only this particular area we need to find out. And so for formula for this it will be, so integration, so the area will be equals to integration from pi by 2 to 3 pi by 2 fx dx. So we can write integration pi by 2 to 3 pi by 2, the value of fx is e to the power x cos square x dx. So already we have determined this value. e to the power x cos square x dx in the second problem or this particular question. So we will just use that. So the area will be, we are getting, it is e to the power x divided by 5 sin 2x plus e to the power x by 10 cos 2x plus e to the power x by 2, and the interval is from pi by 2 to 3 pi by 2. So the area will be, see here, the area will be 2 e to the power 3 pi by 2 divided by 5 minus 2 e to the power pi by 2 divided by 5 is equals to, we are taking common 2 e to the power pi by 2. So 2 e to the power pi by 2 minus third bracket e to the power pi minus 1 divided by 5. So this just we need to remember. Just we are taking the common and the answer is here. So e to the power pi minus 1 divided by 5. So this is the area. This is the value of the area that is under the curve of the shaded region. This area already we have calculated, and this area is 2 e to the power pi by 2 e to the power pi minus 1 whole divided by 5. This is the area of this particular shaded region, this particular shaded region's area. Now if you approximate this value, that is also not needed if you don't have, you obviously will not have any type of calculators in your head. So if you approximate the value, it will come around 42.60 approximately. No problem there. If you keep the answer like this, it is okay, no problem there. But if you can approximate, then the approximate value will be 42.60. So in this way this problem is done. Thank you for watching IB360. In next video we will solve the next problem. Welcome to IB360. In this video we are going to discuss the 11th problem of November HL 2018 paper. So let's start the problem. So the first question is, here you can see, find the roots of z to the power 24 equals to 1 which satisfy the condition 0 less than argument of z less than pi by 2, expressing your answers in the form of r e to the power I theta, where r theta belongs to positive rational set or positive real set. So now we will start. So first theory that we need to know, that is de Moivre's theorem. So de Moivre's theorem, this will be needed in this particular problem, de Moivre theorem. So according to de Moivre theorem, we have r of cos theta plus I sin theta whole to the power n is equals to r to the power n cos n theta plus I sin n theta. So this is the thing that we will get after the de Moivre theorem. So here the complex number is expressed as cos theta plus I sin theta. So the same thing we will apply here. So if we try to apply the same thing where we have z to the power 24 equals to 1, then we can get this idea, and we will be able to do the sum in this way, that is r cos theta plus I sin theta whole to the power 24, because z to the power 24, this is equals to r to the power 24 cos 24 theta plus I sin 24 theta. Now the thing is, the complete value is equals to 1, so we can write r to be equals to 1. This is the value that we have got from this equation. So ultimately this equation becomes cos 24 theta plus I sin 24 theta. So the condition here is 0, arg of z is less than pi by 2. So from in this particular interval, whatever we can take for 24 theta is 24 theta is equals to 2 pi n. So we can write theta is equals to pi n by 12. Now for this particular limit, that is 0 less than theta less than pi by 2, we have the value for n from n is equals to 1, 2, 3, 4, 5. Only this particular values n can take. So in this way, the n value we have got. So the theta values will be like this. So the value for z will be like this: e to the power I pi by 12, comma e to the power 2 pi by 12, comma e to the power I 3 pi by 12, comma e to the power I 4 pi by 12, and e to the power I 5 pi by 12. So again, one more thing, the value of r is equals to 1 already we have told. So it is in the format of, now you can say it is in the format of r e to the power I theta, where the theta value will vary from pi n by 12, where the n values will take from 1, 2, 3, 4, 5. So this problem is done. This was a very easy problem. And later, so ultimately the value of z in this particular interval is just 5 values we can take: I pi by 12, I 2 pi by 12, I 3 pi by 12, I 4 pi by 12, and I 5 pi by 12. One more thing, I am not reducing the denominator and numerator of the I 2 pi by 12, so it can be pi by 6. So I am not reducing the particular things, because later on it will help us to do the later problem. So that's why I am not changing each and a, I am not changing anywhere. So let's do the B problem. So let's start. Show that the real sum, for any complex number z equals to x plus iy. Say this is one complex number, so real part is x and imaginary part is y. So ultimately we have five complex numbers. We have five complex numbers because we got the values for the z, that is equals to the power I pi by 12, that was e to the power I pi by 12, then it was e to the power I 2 pi by 12, then e to the power I 3 pi by 12, then e to the power I 4 pi by 12, and e to the power I 5 pi by 12. So these five particular complex numbers we have, and if we express these complex numbers, then we will have, just see this particular part. So it is basically e to the power I pi by 12, and in the previous slide we have discussed the de Moivre's theorem. So from here you can write, I am just expressing one, so let's express this particular complex number. So it is basically cos 3 pi by 12 plus I sin 3 pi by 12. So as you can see, this is the elaboration of this particular complex number in trigonometric format. So ultimately cos 3 pi by 12 plus I sin 3 pi by 12, this is the real part and this is the imaginary part. So after getting the real part and imaginary part, what we need to do, in the question we have been asked to add all the real parts, and that is we have to prove that is equals to all the addition of the imaginary part. So whenever we are doing this problem, so ultimately the real part, real s is equals to cos pi by 12 plus cos 2 pi by 12, these are the angles, plus cos 3 pi by 12 plus cos 4 pi by 12 plus cos 5 pi by 12. So we have the 5 real parts of 5 complex numbers. Now imaginary of sum will be sin pi by 12 plus sin 2 pi by 12 plus sin 3 pi by 12 plus sin 4 pi by 12 plus sin 5 pi by 12. So I am arranging this particular part from this side to this side, from this side to this side. So I am getting sin 5 pi by 12 plus sin 4 pi by 12 plus sin 3 pi by 12 plus sin 2 pi by 12 plus sin pi by 12. Just see the fact, that is only you see this part and this part. That is basically from where we will be getting this particular thing, from sin theta is equals to cos pi by 2 minus theta. From this particular formula we can tell that is cos pi by 12 is equals to sin pi 5 pi by 12. So cos pi by 12 is equals to sin 5 pi by 12. We can easily say that. And after all this particular term will be equals to this particular term, this term is equals to this term equals to this term, and this term equals to this term. So ultimately from equal points we can write the real sum is equals to imaginary sum. I think it is clear to you, because the formula, that is sin theta is equals to cos pi by 2 minus theta, from this particular formula we are getting the complete answer. Because, and one more thing, the arrangement I have done in such a way that the corresponding terms, if we check, the corresponding terms will be equal. So in this way this particular problem can be done. So we have shown that real part is equals to imaginary part, or the summation of the real part is equals to summation of the imaginary part. Now the second question of B. By writing pi by 12 as pi by 4 minus pi by 6, find the value of cos pi by 12 in the form root a plus root b divided by c, where a, b and c are integers to be determined. So this is again a very simple question. So we need to find out cos pi by 12. So our determination is to find out cos pi by 12, where pi by 12 is expressed as pi by 4 minus pi by 6. So in this way it is expressed. So ultimately we can write cos pi by 12 is equals to cos pi by 4 minus pi by 6, and we know the formula of cos a minus b equals to, we have the formula, that is cos a So cos A cos B plus sin A sin B. So this is the formula. Obviously, you need to remember all the formulas to get a good mark in your particular examination. So from here we can write it is cos pi by 4 cos pi by 6 plus sin pi by 4 into sin pi by 6. So the value of this will be root 2 by 2. Just we are taking in the format, it is basically 1 by root 2, so that it will be same. So that's why just how we will get that root 2 by root 2 into root 2. So we are getting root 2 by 2. Just to get a particular solution in denominator 2, to keep the 2 in the denominator, we have just done this modification. So root 2 by 2 into root 3 by 2 plus root 2 by 2 into 1 by 2. So ultimately we are getting root 6 plus root 2 divided by 4. So this is the answer. So if you compare this from this particular equation, so A is equals to 6, B is equals to 2 and C equals to 4. So we have found our answer, that is A equals to 6, B equals to 2 and C equals to 4. So it is basically cos pi by 12. Now we will move towards the third question, and this is the last question of this particular problem. So let's solve this particular part. So before solving, we need to calculate one more thing for this question, that is cos 5 pi by 5 pi by 12. We need to find the value of this particular part. It will be needed for us. So we will find out cos 5 pi by 12. So again we can use the previous formula also, that is cos pi by 6 plus pi by 4. So the formula will be cos pi by 6 cos pi by 4 minus sin pi by 6 sin pi by 4. So we are getting the answer to be root 3 by 2 into root 2 by 2 minus we are getting 1 by 2 into root 2 by 2. So we are getting the answer to be root 6 minus root 2 divided by 4. Please keep this in mind, that is cos 5 pi by 12 is equals to root 6 minus root 2 divided by 4. Now the summation, we need to find out the summation. So let us start with the real part. So real s equals to, already we have done it, cos pi by 12 plus cos 2 pi by 12 plus cos 3 pi by 12 plus cos 4 pi by 12 plus cos 5 pi by 12. So this is the part. So from here we can write this, already we have calculated this part, that is root 2 plus root 6 divided by 4. These are the angles. Please try to understand the math properly, because this is very easy problem. And this is root 3 by 2 plus we have root 2 by 2 plus we have 1 by 2 plus we have root 6 minus root 2 divided by 4. So to find the value of this particular part, we have calculated it already. So from here we can write 1 by 2, then root 6 plus 1 plus root 2 plus root 3. Just simple common here. So we can write 1 by 2, then 1 plus root 2 into 1 plus root 3. Again, we can also write, that is for s is equals to real s, we can write real sum into 1 plus I, as real sum is equals to imaginary sum. So this formula we can use, the sum is equals to real sum into 1 plus I. So ultimately the sum becomes, so s is equals to real sum into 1 plus I. So we can write the real sum is 1 by 2, 1 plus root 2 into 1 plus root 3, and this part, that is 1 plus I, it is added. So the value of s is determined. So in this way this problem is also done. So thank you for watching IB 360. In next videos, we will discuss some later papers. Thank you.